Hi, this is lesson 1.3b, the second part of the previous lesson, and this will be comparing real numbers. So let's get started. Okay, as I said, 1.3b, comparing real numbers. The standard statement today is I can compare real numbers and make statements of inequality. Talked about inequality statements last spring. So that is something that we'll have to remind you of today. And again, we're still working from standard NS2. So you should now know how to do rational approximations of irrational numbers. To compare the size of them, you should be able to locate them on the number line, and you should be able to estimate the value of the expressions. So let's move on. Here's my little math meme today. It's basically saying that complex numbers are eaten by real numbers, which are eaten by integers, which are eaten by whole numbers, which are eaten by natural numbers. Complex numbers, by the way, include the imaginary numbers as well. So that's something we won't be discussing much in this grade. There's my math meme. And I'm going to close myself out here so you have a little bit more space to see. So review, the diameter of a meteorite in millimeters is calculated by calculated differently by the four people below. So we have method 1, Joe says the diameter of the meteorite is square root of 18 millimeters. Lisa uses method 2 and she says it's 13/3 millimeters. Pablo uses method 3 and he says it's 4.6 millimeters. And Julian uses method 4 and says it's 4 pi over 3 millimeters. Also said 4/3 times pi millimeters. Two ways to read that number. We're going to order the results from least to greatest. So how are we going to do that? Well, we have to get them all into decimal equivalents. So we have one that's already a decimal. That one is right here. That one we won't have to change into a decimal because it's already a decimal. So that's one less we have to do extra work on, right? So let's begin. So we're going to approximate square root of 18 first. And this should be coming pretty easy for you now, hopefully. Find two consecutive numbers that when squared will give you an answer with 18 in between both numbers. Look at your doubles. So 4 squared is 16 and 5 squared is 25. 18 is going to fall between there. It's going to be between 4 and 5. So step 2 is to ask yourself, is 18 closer to the answer of 4 squared or to the answer of 5 squared? Well, you should say it's closer to 16 than it is to 25. So there's 4 squared or 16, there's 5 squared or 25, and square root of 18 is pretty close to 16 there. It's closer to the 4. And then we find the middle number between 4 and 5. Add up 4 plus 5, divide by 2, you should get 4.5. And you're going to square that and get 20.25. So now that number is going to be our upper limit. We are going to eliminate this upper limit now because square root of 18 is going to be between here and there. So let's ask yourself, is 18 closer to the answer to 4 squared or to the answer to 5 squared? I think we just did this. Maybe it's just repeating what I just did. I think it is. So we'll move on. Okay, there we are. So now we are going to get an even better estimate, or just a better estimate, using decimal graduations with our new upper limit of 4.5. So we're going to put some approximations up there. 4.1. Why did I start with 4.1? Because I'm not going to go any higher than 4.5 now. So 4.1 squared, 4.2 squared, 4.3 squared, 4.4 squared, and then we know what 4.5 squared is. So where does square root of 18 fall between these numbers right here? Exactly, it's going to be between these, well, let me just circle it here. It's going to be between those two, right? So let's clear that. Got our thing will show us that. Yep, so between 4.2 and 4.3. So now we're going to find an even better estimate. So we have 4.2 as our lower limit and 4.3 as our upper limit. We square them, and then we find the exact center by adding 4.2 and 4.3 and dividing by 2. We get 4.25, and we square that, we get 18.06, which is very close to square root of 18. So we know that square root of 18 is between 4.2 and 4.25. So we are going to choose our final approximation. What should we choose? 4.24 squared. That's a little bit closer than 4.25 squared. But on a test, if you said 4.25, that would not be incorrect. So 4.24 squared is 17.97, which is 3/100ths of a point from 18, whereas 18.06 is 6/100. So we're talking very small difference. So now we've got to go back to the other numbers we had there. So I went ahead and did all the other numbers. So 4.24 is what we decided for square root of 18. 13/3, we're going to divide 13 on the inside, 3 on the outside. We're going to end up with 4.33 doing that. 4.6 can just stay 4.6. And then 4 pi over 3 is really 4.18. Now, how did I get that? So we have 4/3 times pi. Like I said, this could be written as 4/3 times pi. So I'm going to take 4/3 and divide the 4 on the inside and the 3 on the outside. And I'm going to get 1 and 1/3. Right? Or if I was going to put a 0 there and keep going, I would get 0.3 repeating. So basically 1.3. So I'm going to multiply 1.3 times pi. And if I multiply 1.3 times pi, I get 4.18 on the right there. So now that we have all of our numbers in decimal form, we can order them from least to greatest. There's our numbers in decimal form. And we're going to plot them. And again, our number line is going to be between 4 and 5 with 10th graduations in between. There is 4.18. It's going to be between the 4.1 and the 4.2. So that's 4 pi over 3. And then there is our square root of 18, 4.24. That's going to be between the 4.2 and the 4.3. And then we have 13/3, which is 4.33 repeating. It's going to be a little bit past the 4.3. And finally, we have 4.6, which is going to be right on the 4.6. So now we can easily order them from least to greatest. There's our number line again. 4 pi over 3 is first. Square root of 18 is second. 13/3 is third. And 4.6 is fourth. They are now ordered from least to greatest. Least, farthest right is the greatest. Okay, it's your turn to try a review problem. See you back in a moment. Okay, moving along, let's begin our new information here. We're going to compare rational numbers, or irrational numbers, I should say. So we're going to compare using less than, greater than, or equals to. So we're going to figure out what goes in the circle, which one of those signs. We have square root of 3 plus 5 and 3 plus square root of 5. Now, on these comparison ones, where we're not where we're ordering them, but when we're comparing them, we don't have to be exact, as close of an exact approximation as we do with ordering numbers. So we can just go to one decimal place if we want. So let's do the first one. Do a rough approximation of square root of 3. So what's a rough approximation of square root of 3? Well, 1 squared is 1 and 2 squared is 4. So the square root of 3 is going to be closer to 4. So let's pick something that's a little bit past the halfway point. Halfway between 1 and 2 is 1.5. So we're going to go a little higher because square root of 3 is closer to 4. So let's pick 1.7 for square root of 3. Again, we don't have to go through all those steps because all we're doing is getting a rough approximation. So we're going to put 1.7 for the square root of 3, and then we're going to add the 5. So step 2 is going to be to do a rough approximation of square root of 5. That's on the right side there of the circle. So again, we're going to find those numbers. 2 squared is 4, and 3 squared is 9. We know that the 5 is going to be closer to 4. So halfway between 2 and 3 is 2.5. So we're going to pick something a little bit lower than 2.5. So we pick 2.2. So we're going to put that up there. So it's going to be 3 plus 2.2. So now we have to add that together. 1.5 or 1.7 plus 5. Right here, we've got to add that. And then we have to add 3 plus 2.2 and see which one is bigger. So add each equation using your approximations from step 1 and 2. So 1.7 plus 5 is equal to 6.7. And 3 plus 2.2 is equal to 5.2. So which number is bigger? Pac-Man will always eat the bigger number. Exactly. Sorry, that's my dog. We're going to pick the bigger number, which is 6.7. There it is. Oh, I want to go back. So again, Pac-Man, I like to draw my Pac-Man guy. He's always going to eat the bigger number, 6.7. Okay. So move on, do it again. Now we have square root of 2 plus 4 compared to 2 plus square root of 4. So we're going to do a rough approximation of square root of 2. 1 squared is 1 and 2 squared is 4, and 2 is closer to 1. So we're going to pick something under the halfway point between 1 and 2. 1.5 is right in the middle, so let's pick 1.4. There we are. And now we have to do an approximation for square root of 4, but we know that square root of 4 is a perfect square, so we really don't have to approximate anything. We know that it is exactly 2. So square root of 4 is exactly 2. So we're going to put that up here, 2 plus 2 on the top there. And then we just add them together. So step 3 is to add each equation using your approximation from step 1 and step 2. So 1.4 plus 4 is 1.8. 2 plus 2 is 4. Which one's bigger? Right, Pac-Man eats the bigger number. All right, can't resist. Got to draw Pac-Man again. There he is, eating the bigger number. I love that game, Pac-Man. Okay, now it's your turn to give it a try, comparing numbers. How did you do? I hope you did well. I'm sure you did. Let's move on a little bit here. Finding rational numbers between irrational numbers. What on earth does that mean? Well, let's take a look. Give an example of a rational number between square root of 11 and square root of 13. We want to put a rational number, right? A rational number can be written as a fraction, right? It can repeat, or it can also non-terminate but repeat, right? So do a rough approximation of square root of 11. So 3 squared equals 9 and 4 squared equals 16. And we say square root of 11 is closer to 9 than it is to 16. So we're going to pick something under the 3.5 mark. So we're going to pick 3.3. Now we have to do a rough approximation of, that should say square root of 13. Let's see if I did that right. Put a 3 there and see what happens. So 3 squared is 9, and 4 squared is 16. So square root of 13 is closer to 16. So we're going to pick something a little above 3.5. So let's pick 3.6. So 3.5 is between square root of 11 and square root of 13. Should have kept that 3 there. Why did I pick 3.5? Because I have to go between 3.3 and 3.6. So 3.5 is between the approximation of square root of 11 and the approximation of square root of 13. That's how to get a rational number in between two irrational numbers. Let's do that again. Give an example of a rational number between square root of 75 and square root of 77. Do a rough approximation of square root of 75. 8 squared is 64 and 9 squared is 81. Square root of 75 is closer to 81, so we're going to pick something above the 8.5 mark. Let's pick 8.6. Step 2 is the rough approximation of square root of 77. We're going to use the same two numbers, 8 squared and 9 squared, and 77 is closer to 81. So we're going to go a little bit higher than 8.6 this time. So we're going to go with 8.7. And then we have to find a real rational number in between 8.6 and 8.7. So in between our approximations of 8.6 and 8.7, we will find a rational number that we can place there. So we are going to pick 8.65 because 8.65 is going to be between this lower limit and this upper limit. Okay? Do another one. Give an example of an irrational number between 6 and 8. Ooh, this is the opposite now. Before we were finding a rational number between two irrational numbers, and now we have to find an irrational number between two rational numbers. Okay? So list your common perfect square roots. Square root of 9 is 3, square root of 16 is 4, square root of 25 is 5, square root of 36 is 6, square root of 49 is 7, and square root of 64 is 8. That's just your doubles. Find a non-perfect square between square root of 36 and square root of 64. Why did I pick those two? Because square root of 36 is 6, square root of 64 is 8, and our number has to be between 6 and 8, and it has to be an irrational, non-perfect square. So we can't pick 49, square root of 49, because that's a perfect square. So we have to pick something else. So square root of 50 is approximately 7, right? It's not exactly 7 because we can't pick square root of 49 because that's exact. So it's close to that, but not quite. So square root of 50 is approximately 7, which would fall in between the 6 and 8 number. So square root of 50 is approximately 7, so this is between 6 and 8. Okay, give it a try, and we will see you back in a moment. Okay, let's do a little higher order thinking. So Mueller's E is approximately 2.7182818284. Never repeats, never ends. So between which two square roots of integers could you find this number? Well, square root of 7 is 2.65, and square root of 8 is approximately 2.83. So wouldn't you say that 2.7 is going to fall in between these two numbers here? So 2.7182818284. 4 is going to be in between. So let's show how that works in the number line. There's square root of 7, 2.65. There's the square root of 8 at 2.83. And there is our Mueller's E at 2.72. So we have a number on either side, a lower limit, and we have an upper limit. And then we can plug in this number right here in between, right? There we go. Apologize, I think that's my daughter in the background. I apologize for that. Okay, we are now on homework. And again, our homework will be on Google Classroom. So we will see you back in our next lesson. Have a good day. Bye.